Now we're going to be looking about radius and interval of convergences. And so for the given power series on these, find the radius of convergence and find the interval of convergence. So in general, for both of these, you have to start off with using the ratio test. Sometimes, very rarely, you'll use the root test to find the interval of convergence. But for the most part, you're going to find you're going to use the ratio test. So we're going to take the limit as n goes to infinity of the ratio. And the ratio is the absolute value. So I ignored the -1 part. So it's going to be x to the n plus 1 over n plus 1 factorial. And I'm going to be dividing by the nth term or just doing it as multiplying by the reciprocal when I do the ratio test. Okay. Now for a ratio test, this must be less than 1 to be convergent. Right? So we are going to do some canceling. That cancels and that cancels. So I have the limit as n goes to infinity, absolute value of x over n plus 1. That's going to equal 0 because no matter what x is, if x is a finite value, as n goes to infinity, this will always approach 0. So this always converges. Okay? And so if it always converges, the radius we say is infinite. Or the interval of convergence is basically anything between positive and negative infinity, like that. Okay? Let's do number 2. So we're going to take the ratio test again. Limit as n goes to infinity. When I do absolute value, it just gets rid of this, the -1 part. So it's going to be x minus 3 to the n plus 1 over n plus 1 times n over x minus 3 to the n. And this is going to cancel with that, and that's alone. That just leave that alone. We can bring the x minus 3 out because in limits, if there's no n term in there, you can just bring it out. So it's going to be x minus 3 times the limit as n goes to infinity of n over n plus 1. And remember, this, like, you just look at the dominant terms, or you can use L'Hopital's rule, because it's going to be infinity over infinity. But you'll find that this limit is 1, so this limit is x minus 3. Oh, with an absolute value, by the way. Now, this has to be less than 1 to be convergent, right? But that's what the ratio test is. The ratio of those terms has to be less than 1. So when you have it in this form like this is the radius. The radius is going to equal 1. Okay, because really what you're saying is if x minus 3, the way you think of it is that the distance from 3 is 1. That means like x can be between like 4 and 2, right? This interval width, and any value between there, right, will have a distance of less than 1. The absolute value of the distance will be less than 1. Now, so that's the radius of convergence. To find the interval of convergence, so if I were to simplify, this is really saying x is less than 4 is greater than 3. Sorry, greater than 2. Now, to find the interval of convergence, we actually have to check the boundary, because one of the things the ratio test does is if it's exactly equal to 1, the ratio test is inconclusive. It may converge, it may not converge. So you actually have to check the boundaries specifically at x equals 2 and x equals 4 separately. So if x were equal to 2, the series would look like this. -1 to the n, 2 minus 3 to the n, over n. And this would be the sum from n equals 1 to infinity, -1 to the n times -1 to the n, over n. But this -1 to the n times -1 to the n, that's always going to be positive, right? Because both of them might be negative at the same time, so that's going to be 1 over n. And this diverges by the p series or harmonic series. You can either say it's a harmonic series or p series. How about x equals 4? Well, that's going to be sum from n equals 1 to infinity, -1 to the n. And then I'm going to do 4 minus 3. I'm going to plug in 4 minus 3 here for x equals 4. And that's going to be 1 to the n, positive 1 to the n. 1 to the n is just 1. So this is sum from n equals 1 to infinity, -1 to the n over n. Now this is alternating series, and the limit, the way you do alternating series test to see if it converges is you take the limit as n goes infinity of just the term without the -1, the absolute value of this, and this equals 0. So this converges by the alternating series test. Okay? So we know that for x equals 4, it converges. For x equals 2, it doesn't converge. So that means our interval of convergence, you want to include the 4 on the interval like that. Okay? So the key part in general, for interval of convergence, so radius of convergence, you start with doing the ratio test. And then to find the interval, the exact interval, you have to check the boundary, the end conditions. Because in the end conditions, the ratio test doesn't tell you if it converges or not. Thanks for watching. If you enjoyed this video, I go through a lot more of these exact kinds of problems with much longer videos on my website. It's entirely free. Check out the link in the description below.